Hi everybody, welcome to the fifth installment of the Mob AI tutorial. So a bit of housekeeping first before we get on with the tutorial as it is. I wanted to show you this align heading with actor behavior tree task that we did in a previous video. It's actually in our guard tutorial thing. And one thing we did was in this particular behavior tree task, we'd casted it to a guard controller or one of the guard util controllers or something. Well, actually, we need to change all of the nodes that we did for the cast into AI controllers, so we can just take any AI controller and make sure it's aligned. So, like if you look for any particular type of controller, we want to take it as an AI controller in this case. So AI controller is the base class for all of those objects. So you don't actually technically need this node. It's just that, well, you'll see in the behavior tree later on, when we're doing some testing, that you can use this node there, and you actually want to make sure that the AI controller can turn depending on, no matter who he is, as long as he's an AI guy. Yeah, so there you go. That's one thing I wanted to show you. So what we're going to do for this part of the tutorial, well, oh yeah, here's the other thing before we start that. Player character in the graph. What I've done is I've migrated from a first-person shooter starter template. I've migrated the projectile. Now, the reason why I did that was because I wanted to be able to shoot something at the AI guy to test his threat detection selection stuff. And I thought it'd be nice to just shoot a projectile at him. So when I press the G key, let's just show you that a bit better. When I press the G key, I'm getting the player pawn, getting its rotation, setting the rotation into a transform, getting its location, adding a bit of a forward vector into it, and then setting that as a location. And then we're using that transform to be the spawn transform for this spawn actor node, which when the G key is pressed, it will spawn a projectile at basically just above the character. So I offset the spawn point here by 100 in the Z just to make it above the character. It sets itself as the instigator, so it sets this controller as the this player character as the instigator, but it turns out that that's no good because, yeah, the spawn actor, so we've added a creator value to the actual projectile, which I'll show you. Actually, no, I'll show you that now. So projectile is over here, projectile. So projectile, we've added a creator, which is a controller. We've called destroy actor on that, but I've actually snuck a apply damage node in. So basically the creator is a variable that's set when we spawn this guy, this projectile. And when it's hit something, it just calls the apply damage on the actor that gets hit, and it uses the creator as the instigator for that apply damage. So most of the time for things in the world, this apply damage will do nothing, but the AI handles the apply damage function stuff. So we want to pass in who started the damage so that we can use them as a threat. So we have this creator node in there to pass that in. So again, player character sets itself as the creator on the pawn that it just created for the projectile. So basically it gets a reference to self, gets the controller from the pawn. So basically from this player we get our controller, we set that as the creator, so that when it does the projectile and calls apply damage, the controller is passed into it. Sorry, the instigator is passed into it, so this creator value is passed into that event instigator. So basically the instigator on our apply damage node is the controller that caused the damage. So basically who controlled it. Could be an AI controller or a player controller in this case, which is us essentially. So what else? So what you'll see is that when we spawn we've got our player character, and this guy's going to go and whack a bunch of, this guy is the one that we're going to fire at, is, oh yeah, okay, so he's the AI guy, and essentially he's doing a utility based decision. Yeah, I can basically outrun him by, I've set the jump height for this guy to be like 1200 or something. So he does a utility based decision. You see a whole bunch of spam there, and what I can do is I can kind of pull aggro on him by shooting him a few times with my silly projectile, and he will go and aggro on those guys if he can't get to me essentially. So over time he forgets that basically there's a part of the utility based decision is how much damage I've done to him, and I'll show you how that works later on. But as it goes over time, that value becomes less and he gets more interested in those guys rather than me. So you go, he's just essentially aggroing on the nearest guy to him right now. We'll show you the utility stuff. So this is just a test to make sure, yes, I can pull aggro from that guy. So theoretically any AI guys that beat on him will pull aggro from him, so he'll target whoever's doing damage to him more than just the sort of distance check. And of course all of this is kind of a moot point because we're going to move to the EQS system for all of this stuff. So what I'm probably going to do is do this last tutorial just to show you what I was actually kind of aiming for. Yeah, he's just killed that guy there. Obviously these guys aren't reacting to him, but that's kind of how I planned for this stuff. I'll show you how this works, and then we'll kind of bin it off and redo it again using the EQS system once that goes out of experimental. So we'll probably redo the whole thing with 4.7 when that comes like into the stable build and you can all get it. And we'll fix all of the problems with like using 4.3 and stuff, because this is still 4.3 again, sorry, 4.4.3. We need to get rid of that. So there you go. That's what we got so far. I shall now show you the code. Okay, so let's get on with building this guy. So there's a few things that we're going to need to add to the controller. Most of the code is going to work in the controller here, so we're going to be extending that quite a lot. So the first part is, let's just run through and make sure that these functions work. So there's an actor has tag function. Now one of the things that we probably want in here is to check to make sure that we're properly checking this. So I've noticed that there's a few problems with some of the way I've used the arrays and variables, so we're going to fix that now. So one thing we want to do is set this guy up. So we're resetting it to false at the start. We're then doing the for loop. We're saying if it's true, then again we're setting the has tag to true, and then we're doing the break. I notice there's a problem with doing it the way we had it before, so, and then finally here we break that. So if we just clean it up a bit. I hate the way the for loops kind of have to loop around like this. It's not very nice, but hey. So what we're doing here is essentially saying we're passing in the actor, we're passing in the array of tags that we were looking for, we're looping over the array of tags we're looking for, we're saying if the actor that's passed in has got that tag, this condition is true, then we're setting the has tag to true. So it'll basically loop around for all of the tags we've got in that array. So we're only checking one tag right now, so it's actually a little bit of overkill for this, but that should fix that particular function. So the next function that we kind of need to look at is the add actor to threats array. Now one thing I've noticed is that in this one it's this part here that's a problem. Set members in Threat Struct. It doesn't seem to actually work the way I intended it to work, so we're just going to have to make sure that this whole sort of thing works properly. So what we're trying to do here is, I'll just go over it again. We're trying to add an actor to this array of threat structures, and the threat structure is, if you remember, is a struct that we defined earlier. So we're trying to sort of add one of these. So the first thing we do is we check if we've already in the threats array. So we loop over them, looking for, break that threat struct, get the actor out of it, compare it if we have got that. So we're basically doing the same loop system as we did with that other boolean. Set the actor in array to false, set it to true if we ever find it, and if that's true, then after this function, if it's true, we could actually make that a function, I suppose, but let's do it some other time. If this boolean is true at the end of this, then the last seen index is set to the one that we saw. So if the actor is already in the array, so what we're saying is we're checking that bool after we've done the check here. If it's in the array, we do this part. If it's not in the array already, we add it. And this is the bit that's kind of wrong. What we actually want here is to set the array element. So if we get this threat struct again and set array element. So the difference is that whole set threat struct thing just didn't seem to actually function. I'm not entirely sure what it was meant to be, but it didn't do what we wanted. So we've done a break threat struct here. We need to make threat struct. So I'll just move the microphone a little bit. So we're making a threat struct, and then we're going to set that as the item in the array, and we want to set the last seen index into the index that we're setting. So essentially what we're saying here is if we've seen the guy and we already know about them, we're just going to reset the time since they last were seen. So everything else we can just pass straight through. And a lot of these things we're not actually using yet, but we might get to that at some point. So that should do it for that one. So this break and make thing is pretty much the common pattern, and we're going to have to go through a lot of code to fix all of those. I was just hoping that the other node would actually work this make threat struct thing, but it turns out, sorry, not make threat struct, the set threat struct thing that we used before, but it turns out it doesn't actually work. So in other words, for the final one, if we haven't seen the guy before, we're just going to add him to the array, so that's kind of fine really. It's going to go straight into here. We could turn off the print for that if we needed to. So that's that actor, add actor to threat. So we've now fixed the actor as tag, add actor to threat. So there's a few other functions and variables we need before we sort of really get started. And well, we might just sort of add a few of them for now and then see where we get on. So let's just walk through the logic here. We can ignore the herd thing. So we're basically just running the behavior tree as per normal, right? What we're saying is set up our behavior tree to run. When I see an enemy, what we're going to do is, what we want to see is if it's already in the, so we've got this actor has tag function which we've done there. If the actor does have the tag of enemy, so we're interested in it, we're printing out if we don't see the guy, he basically isn't an enemy, we're going to ignore him. If he is an enemy, we're printing a string, probably want to get rid of that for now. And we're adding the actor to threat, so add actor to threat should work now, so that should be okay. Now, there's kind of a problem here. Well, there's a few problems actually that I've noticed as I've sort of been going through the code a bit. And that is that when we add the actor to the threat list, to the list of sort of threats, we're literally just adding the actor in. But what happens to get rid of the actor? What happens if we kill the actor, or what happens if something else kills the actor? So we've got a bunch of threats, and some of them might actually die. Now, I don't know whether you're aware of this, but one of the problems with Blueprint is that they don't get immediately notified when an actor goes away. What the actor actually does, if you call destroy actor on something, it actually gets garbage collected. And the garbage collector is the thing that kind of removes the actor from the world. Now this is a bit of a problem for us because the garbage collector doesn't run when we expect it to. It runs whenever it feels like there's enough memory to free. So if you imagine that we've got a bunch of actors that we're tracking for threats, we might actually be tracking a threat that doesn't exist anymore, which is a bit of a problem. So one way of fixing that is for us to add a new binding. So we can bind an event, but we want to bind an event. Let's just see if I can get it from here. Bind event. Nope. Well, let's do it from the pawn guy. So bind event. Again, context sensitive. Bind event on actor destroyed. So what we want to do is, once we've added the guy to our threats, we need to bind a new event. So let's create a custom event. Let's custom event. and let's call that on threat destroyed. And with this event we can just drag the guy here. Let's do a print string just to show string. And just put in threat destroyed. We can print that. Yep, that should be okay. And then, so one thing you can do to ensure, so we know that something's been destroyed. We know that one of the actors, so you do get a notification of destroyed, but we don't know which actor it is, and this event doesn't actually tell us, which is kind of annoying. But one thing we want to do is we want to say, okay, so that thing's been destroyed, although technically it's not been removed from our actor list. What we actually want to do is we want to call the garbage collector. Now this isn't necessarily the best way to do this. I'm still trying to find what is a better way of doing this kind of logic. But what we're essentially saying here is, just comment this code as we're going along. Bind event for if any threat is destroyed, so we can remove them from our threats array. Destroyed. Oh, epic, really. That caret positioning is so wrong. So anyway, so what we bound an event. Essentially, this is a delegate, I think called a delegate. And what it does is that when it let's just, I did do that, didn't I? Oh, oops, no, don't need to do that. What the delegate does is it fires the event, the custom event, whenever it sees this one. So essentially, we're binding a method for when this object is destroyed, and it's going to call back this node here, which then does the execution chain. So let's just compile that and save it. So what's next? Well, there are a couple of things that we still need to fix up. Let's see. Well, let's do the tick handler next. So we've had a look at our cpawn. We've made sure that that's okay. Next, we need to make sure that the ticks handling is working. So every tick, if the elapsed time, so we're increasing the elapsed time and setting it here. If the elapsed time is greater than the threat evaluation frequency, and that is true, then we set elapsed time back to 0 and we do some evaluation. So we're doing this evaluate enemies. So that should handle the ticking okay. So we need to do this evaluate, have a look at this evaluate enemies function. So evaluate enemies is this custom event, and it's this bit that's kind of, it's not a function, it's an event, but anyway, it's the evaluate enemies function that's kind of a little bit wonky. So currently we haven't really fleshed this out at all, and we've got this set members in Threat Struct, which, as I mentioned earlier, is kind of not working properly. So let's fix this guy up. I'll just give myself a little bit more room here. Hopefully you can see that. So what we're doing is we're saying, okay, so we want to calculate the utility score of each value. So there's a couple of things that we probably want to do. We want to, first of all, we break the threat struct, which is fine. But actually we want to calculate some utility and maybe alter some values. And then we're kind of trying to store the utility back in a weight value inside the same array. So again, this guy doesn't work properly, so we need to delete that one. And what we do want to do is another make threat struct. Help if I spell it correctly. I think my computer's thrashing away a little bit there, but not to worry. So what do we want to do? What do we want to put in this guy? So one thing I think we probably want to do is we probably want to we want to update some values. So which values can we safely update? And which values do we want to calculate? So for the loop body, what we probably want to do is we want to calculate some utility score. We want to figure out the distance to actor and use that. Or rather, maybe what we should do is we should set up a new function and use the sort of utility function for that. So let's create a new function and call it well, we've got the distance to actor node, but that's telling us the actual distance value. So let's call it something like calculate distance utility, and it's going to take as input a threat structure. We'll call that one threat, and so I think that should do us, and it's going to output at least it's going to output a floating point value, which is the utility. Did I spell that right? Yes, I did. It's gonna return this utility. So basically what we want to do is we want to say, so for each threat we're going to score its utility, right, with this function. So first thing we want to do is break that threat struct so we can get its values. Open that out a bit. So if we go back to the event graph, what we're actually doing is kind of this stuff really. So we can actually cut that out. Oops, didn't want to do that. Cut the comment box out as well. So get rid of that. Calculate distance utility, paste those into there. Or not. Oh yes, that's kind of weird. So what we're saying is we're going to use this distance curve to return our utility value. It just means that when we're like summing some of the utility scores up, it's easier to call this function. The event graph looks a little bit tidier, that's all. So what else do we need to do? Well, we can call that guy, let's call it calculate distance utility. So we'll call that function. We're going to pass the threat struct in that we're actually calculating utility for. So let's just move that up there a bit. So that's the first thing we're going to use. But we're not just going to add the, we're not just going to use this one, right? So we want to also, we could just use this and pass that in as our weight value. And then what we're looking for later on is the maximum of those weight values. But we actually want sort of a little bit more complexity in our utility function, I think. So so let's look at what else could we need. Well, we might want to look at how much damage has been done to us by the enemy, by the particular threat, and we use that to sort of also scale our threat up. So let's create a new function for that and call it something like calculate damage utility. And the idea of these utility values is basically a way of scoring multiple inputs, multiple possible types of inputs. So you can obviously you can imagine all sorts of things for yourself, you know, like different types of whether you like the person or not. Threat struct. So we're taking an input parameter of the threat struct. Once again, we'll call this threat, and our output parameter is again a float. So that is our utility. So what we actually want to do with this particular guy is that we want to again break the threat struct, and we're going to do a simple calculation. Basically, we're going to say, okay, so damage received. Now, so one thing we want to do is we want to see essentially the ratio between what our maximum health is and how much damage was received from the particular threat. So we need a new variable here. Let's give it a float and we'll call it max health. So we're saying, given our damage received, we're going to divide it by our max health. Let's just make sure that that's public. Divide it by our max health, and that is the ratio essentially of how much damage we've taken. Now we'll probably want to make sure that these floating point numbers stay within a particular range, so we'll need to bear that in mind. So going back to our graph, so we've calculated distance utility. Now we can calculate damage utility the same way. So what we'll probably do is, let's just drag off there. Again, what we're doing is essentially we're adding these two guys together. And that's going to give us the basis for our score. We're calling it weight right now, just because that's how Kevin Dill referred to it in his article. So let's pass that weight into there and add those two together. So the next thing we want to do is we're making the threat struct up, so we'll probably have to do some stuff in here to make sure that we're elapsing time and those kind of things. And then we need to call again set Let's do it from the Threat Struct again. And set array element. So we're going to do it so we're going to set the array element in the Threat Struct, and the array index is this guy here. So what we're saying is we're going to loop over each threat in the threats array, and we're going to score its value based on these two utility functions, which are just simple calculations. We're going to add those things together, and we're going to store that in the weight. So that weight we can then loop through the array again, looking for the maximum weight, and return that as our best threat. Now, before we do that, we probably want to I was just wondering if we should print this stuff out. Yeah, let's do that. So let's do a print string move that somewhere up here. Now we want to actually have a formatted string here, because we're actually going to print some other stuff in. So let's give ourselves a bit more room. We're actually going to change this stuff as well, but yeah. Make Threat Struct, we're going to plug that guy into there, because that's the one we're actually setting up. Now, one thing we want to do is we want to get the name of the actor in the struct so we can print it out. Well, let's just add a format string. Oh, why is it context? I swear this whole context sensitive thing's just crazy. It's format text, isn't it? Format text. Format text. See, why did that node not show up? Whatever. And we're going to hardcode a format. So just as this guy is saving, thank you for that. Yeah, it's really nice of you. Save it all. So format text, actor. And if you use format text, it's basically the curly brackets, if we can find it. Wait. Curly brackets again. And when you press enter, it'll give you two nodes. So basically, when you do this curly bracket thing with a number in, it'll actually give you a numbered input. And what we're going to do is we're going to say, okay, so this guy, get name, and we're going to plug that guy into there. So this input will essentially get replaced, we'll replace the bracket 0 thing there. And then we're going to plug in the weight into that, and it'll create a converter node for us to text. And that was nice of it. So yeah, does it actually give us don't like the look of that. Let's just leave it as it is. And then in the result of that, we're just going to print in the string there. Wow. Let's just move that guy down so we can actually stick him on there. Don't care about logging it too much. We're just printing the string so we've got something to display. So what else do we need for these values? Well, one thing we want to do is we want to make sure that the last scene time thing actually works properly. So also we probably want to pass this around but we don't necessarily want to do it straight away, so let's just save and compile what we've got so far. Make sure there are no errors, that's good. So we don't care about the incoming wait. The last seen time, what we're actually doing here is not adding that, we're adding the threat evaluation frequency, because we're only calling this function as often as our threat evaluation frequency. So we're adding that much time onto our last seen time, and then the result of that we're plugging into the last seen. What else do we need then? So damage received. Well, damage received, we probably want to clamp between 0 and our max health, because we don't want it to go negative. But one thing we do want to do is be able to handle taking damage, so that when we take damage it actually gets passed through. So one thing we want to do is we could just pass this directly through, and every time we take damage we just add to it. But the trouble is that means that we never, once you've damaged somebody, they'll never stop attacking you, and that's not necessarily good. So what we probably want to do is we want to slowly decrease this value over time. And as I mentioned before, we really want to clamp this value, so let's just make sure we've got the clamp. And we're going to just hard code a value in here for now. So we're going to subtract 5 from the damage received at every threat evaluation update. And this guy, we probably want to say, okay, max health. So our value is clamped between 0 and max health. And what we're doing is every update we're subtracting a bit off the damage we've received, so that when some guy damages us, we react to it by storing the value, but we kind of forget a little bit about it, I suppose, is the way I'm viewing it. Now we can just pass these distance and rank values through, because we're not actually using them yet. Okay, so we're making this this threat struct up. We can pass the actor through, because we want that to stay constant. So we're essentially calculating the utility value for this guy through these two utility functions. We're setting the array element back, so all we need to do then is look through the highest one. So let's just save and compile there. So we've got this highest threat value, right? And what we're saying is that if we set the highest threat to nothing, and then what we're looking for is the current highest threat. So let's just set this value to, I don't know, minus 10,000, something like that. So every update we're looking for the maximum of this, we're calling it weight, it probably should be called sort of threat or something. So we're going to loop over the loop body, we're going to break the threat struct, we're going to get the weight, we're going to say if it's bigger than the current highest threat, then set that value as the highest threat and set the current highest threat to its weight. Otherwise, just keep looping. So at the end of this loop, we should have the highest threat value. And then all we're doing now is getting this and saying, okay, so the highest threat goes in there. So we're setting the enemy actor's key to our highest threat actor. So there's that's the bulk of what we want, really. We can just move this guy off a little bit because he doesn't really change.